Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to make our big push forward. And what we're going to do is we are going to solve the non-homogeneous system of differential equations. And here I have an example written down, but before I do that, let's put this into perspective, what we've done. At this point, we originally began our studies with y equals ay plus q. And we started out by saying that q was 0, and we found a solution. And then we learned how to solve the simple first-order linear differential equation. Well, look at what we are at now. Now we're at y prime. The vector equals some matrix A times the vector y plus, now we have capital Q, the vector of a source function. And so in this case, our problem q is e to the t and 1. So how do we solve that? Well, I've already given you part of it because you know how to do that. And that is, I gave you the null equation. So let's just make a little note here. And notice this. We already have our null solution. So we can't go any further. We don't have to find that. That would be found by setting q equals 0 and finding that solution. But what we're going to do now is, how do we find our particular solution? So that should really be our directions now, is find y, that's the vector y particular. Well, we're going to use variation of parameters again in a clever application. What we're going to say is this. We're going to say that y particular is instead of c1, we're going to make it c1 of t times the eigenvector 1, 1, e to the t plus c2 of t times the eigenvector 1, 2 times e to the 2t. So in order to solve this, obviously we need to get y prime equals ay plus q. Let's move to our next step. So the next step is where we have to look at what we're solving. So we're solving this problem. We're solving this problem right here. Y prime equals ay plus q. So let's just substitute in our y particular and see what happens. So let's do that now. So first off, we need to calculate y particular prime. Well, here we go. That's going to be the first, so c1 of t times the vector 1, 1 times the derivative of the second, that's e to the t, plus, now we're going to take the derivative of the first, so that's going to be c1 prime of t times 1, 1 e to the t plus c2 of t times the vector 1, 2 times 2e to the 2t plus c2 prime of t times 1, 2 times e to the 2t. Okay, that's y particular prime. And remember that this has to equal a y particular plus q. So let's keep going here. So then a, I'll write this out to help see. This is going to be c1 of t times a, which is 0 minus 213 times 1, 1 e to the t. Yeah, I'm just applying a to y particular, plus I'm going to have a c2 of t times a, which is 0 minus 213 times 1, 2 times e to the 2t plus q, which is e to the t1. Okay, well, when I clean this up, then I'm going to get c1 of t times 1, that's the eigenvalue, times the eigenvector 1, 1, e to the t plus c2 of t times the eigenvalue 2, eigenvector 1, 2, e to the 2t plus e to the t times 1. Okay, and now look at this. If I grab some blue and a highlighter, on the left-hand side, I have some pieces that are they're just opposite, or they're gonna cancel. Okay, so let's just rewrite what we have. On the left-hand side, I have a c1 prime of t. So the left-hand prime that now, left-hand side is I'm going to go to no, let's do it here so we can keep track. So I have a c1 prime of t times 1, 1 e to the t plus c2 prime of t times 1, 2 times e to the 2t. Equals, and on the right hand side, what do I have? I have e to the t and 1. E to the t and 1. And then, oh, look at this. On the left-hand side, I have scalars. There it looks like a rough bit of scalars, but I have two vectors. So let's write our column vectors. They're 1, 1, 1, 2. And then I have scalars now. c1 prime of t e to the t, c2 prime of t e to the 2t. There it is. That's a vector. Equals the right-hand side, e to the t and 1. Whoa, look at this. So we're going to need a bit more room for that. I'm going to copy that. And if you have more paper, great. And hold tight, and I'll be right there, ready to go. I think we're ready to begin now. This might actually surprise you, but look at what we have. We have this interesting problem to solve, and now let's apply Cramer's rule. Cramer's rule. And if you recall, so the first component, the first component, c1 prime of t e to the t is equal to the determinant of b1. Well, the determinant of b1 is e to the t1, and that's where we put the b in the first column, then we put the second column of a, that's 1, 2, and we divide that by the determinant of a, 1, 1, 1, 2. And then, so let's finish that, and then we'll find the next one. So this says that c1 prime of t e to the t is equal to, that's going to be on the numerator, I'm going to have 2e to the t minus 1 divided by, the denominator is going to be a 2 minus 1, so this is 2e to the t minus 1. And let's solve for c1. So c1 prime of t is multiply both sides by e to the minus t, so this becomes 2 minus e to the minus t. And so I can say that c1 of t is 2 plus, is 2t, there we go, 2t plus e to the minus t. We're just going to let our constant of integration be 0 plus 0. And we can do this again. So now I can say that c2 prime of t times e to the 2t is equal to, again, now this is to get our second one, we put the first column, we take the determinant of b2, capital B2. Well, that says we put the first column of a in the first column, and we put the b in our second column, e to the t and 1, and we divide it again by the determinant of the matrix A. We already know that. Well, that's going to be 1 minus e to the t divided by, we know that that is 1. So now C2 prime of t is equal to, I'm going to multiply both sides by e to the minus 2t. So this is e to the minus 2t minus e to the minus t. So we could say that C2 of t is going to be minus 1/2 e to the minus 2t plus e to the minus t. And there we go. Well, look at what we said. Remember, we said that y particular is C1 of t times the eigenvector 1, 1 e to the t plus C2 of t times the eigenvector 1, 2 times e to the 2t. Well, now we plug these in. So this is going to be C1 of t. C1 is 2t plus e to the minus t. And then we're going to have that e to the t times e to the t times, oops, I should use consistent notation, times the eigenvector 1, 1 plus C2. Well, C2 we learned is minus 1/2 e to the minus 2t plus e to the minus t times e to the 2t times our eigenvector of 1, 2. A little bit of simplifying here. What are we going to pick up? This is e to the t. This is going to give me 2t e to the t plus 1 times 1, 1 plus, that's going to give me a minus 1/2 plus e to the t times vector 1, 2. And there is our y particular. And remember, we can check this if we were to take it and plug it back into y particular prime equals a y particular plus q. I hope that helps, and thanks for watching.